Okay, this tutorial is about finding the diameter of a cable, assuming you want to put this cable to a certain load. Now I have this a drawing that I always use. We are going to use two cables, and we are going to suspend a certain weight. My drawing might not be symmetry, but this is 30 degrees, and this is also 30 degrees, and I have certain weight here. Let's put it at 100 kilograms, and I'm asking what is the diameter of the minimum diameter of this steel cable. Basically to resist this 100 kilogram of load. So the wood here is steel, and you know very much that steel has a yield strength of 200 gigapascal. So let's go ahead and calculate what is the minimum diameter of the steel cable. So the first order of the day is for you to create the free body diagram. So I have the free body diagram like so. Let's put some I want to call this as A, and this is B, and this is C, to make it easier to identify. So I have here my weight, which is 100 kilograms times 9.81, and that should give me 981 Newton. And I'll have my tension here. This is TBC, and this is TAC. So that's pretty much my free body diagram. So in order for you to find out what is the stress for this cable and this cable here, we need to find out what is this tension AC and also BC here. So once we know what is the tension, we can go ahead and find out what is the stress that will give the minimum diameter for the steel cable. So so we can go ahead and solve the equation of equilibrium. So I have my summation of forces in the X, which is going to be equal to 0. And I simply have, so this is actually two components here. And I'm going to call this as TAC. Okay, now this angle here, since this is 30, this one is going to be 60 degrees, and this is going to be 60 degrees as well. So I have TAC sine of 60, and this one here is TAC cosine of 60. Similarly, I have here my TBC sine of 60 degrees, and I have TBC cosine of 60 degrees. So if I go ahead and do a summation of forces in the X direction, I will have minus TAC cosine of 60. It's going that way, and I have a plus TBC cosine of 60, and that is going to be equal to 0. That's one of the equation. And if I do summation of forces in the y direction, I will have a positive TAC sine 60. That's this one here. Then I have a minus 981 Newton going down, and I also have a plus TBC sine of 60, and the whole thing is going to be equal to 0. That is my second equation that I need to solve. Now I know pretty much that since this is in equilibrium, my TAC is actually equals to TBC. This is another equation that I get from that relationship. So I can go ahead and solve. I just take from equation number 2. So I have my TAC sine 60 plus TBC sine 60 is equals to, bring the 981 to the other side, is equals to 981 Newton. And since I know this and this is the same, so I can go ahead and say 2 TAC sine 60 is equals to 981. So I can go ahead and solve my TAC is equals to be 981 divided by 2 sine of 60. And if I crunch the number, I will have 981 60 sine 2 times divide. I have my TAC at 566 Newton, and this is 1. Since they are both equal, and this is also TBC. Okay, this is the amount of force that's being exerted on that particular cable. Okay, now since I also know that now if I know what is the basically the forces, which is 566 Newton acting on this particular cable, if I cut this, I will have my axial stress, which is equals to P over A, and A here is basically the this is actually the cross section of the cable. And from this equation we can find out what is the minimum diameter. So my sigma yield I want to take at steel is 200 200 gigapascal, and so I have my 200 gigapascal is equals to my force divided by my A, so I can find out what is my A. And from this A, which is 566 Newton divided by 200 times 9 Pascal, that will give me 566 200 e to the 9, divide that, and this is 2.838 times 10 to minus 9 millimeter square. And I will go ahead and solve D, because I know The cable is actually a cross-sectional. The cross-sectional of the area of the cable is actually pretty much a circle. So I have a pi d square over 4 is the area of the circle, is equals to 2.83 times 10 to minus 9. So I go ahead and find 2.83 times 10 to minus 9 times 4 divided by pi. Then I go ahead and do that. So my d now is whatever is inside that, times shift pi divide the square root of that, and is 0.0001 meter. And if I go into millimeters, I will get 0.06 mm, which is rather small. So you know that if we put something in excess of 1 millimeter diameter, they should be able to withstand that 100 kilogram load. Okay, that's all for now. Talk to you guys later. Bye.